Welcome to The Explainer. I am your flight director, and today we are treating your Cambridge AS and A-level mathematics exam exactly like a high-stakes flight system. We're operating directly out of mission control, and our objective on the central console screen today is Syllabus Section 1.6, Series, Arithmetic Progressions. We're going to analyze this exactly how the principal examiners, our top-level systems engineers, see it. Now, looking at our pre-launch telemetry on the monitors, I want to introduce you to two simulation pilots we track every single year. First, we have pilot Alex. Alex tends to overcomplicate data calculations, aggressively running standard formulas over and over, burning way too much time and fuel. Then we have pilot Sam. Sam is the opposite. Sam ignores structural boundary constraints and real-world contexts entirely, risking complete systemic breakdown. Our mission today is to make sure you don't fly like Alex or Sam, but instead execute a perfect trajectory.
Let's look at the payload requirements. This single component, arithmetic progressions, commands a massive 15% of the total marks on your exam. Think about that telemetry. 15% of your entire flight success relies on this one system. It's the critical mass that can easily mean the difference between a stable orbit, like an A or an A star, and falling back to Earth with a B. You absolutely cannot afford to leave these marks on the table. It requires perfect execution.
Here's our flight plan. 1. The 15% advantage. 2. Core principles and frameworks. 3. The method mark strategy. 4. Principal examiner top warnings. And finally, 5. Final review and mnemonic. Starting with Section 1, the 15% advantage. Moving to Section 2, core principles and frameworks. Let's monitor the approach trajectory.
All right, let's break down the dialogue between our pilots on the high-tech UI console overlay. A lot of students, like pilot Alex, think that if they just memorize the standard structural parameter, like the nth term is equal to a plus n minus 1 times d, they are completely safe to clear orbit. But the examiners explicitly state that the theoretical architecture rests on understanding causal relationships and cross-topic connections. They don't just want you plugging numbers into an equation like a malfunctioning autopilot. They want to see that you truly grasp the behavior of the system. What happens if they feed you a sequence embedded in a geometry problem, like calculating the decreasing perimeter of nested shapes? What if it's a real-world financial context? They treat these command keywords as system parameters, and you need to seamlessly transfer your conceptual understanding to that unfamiliar territory to maintain structural integrity.
On our radar. This brilliantly illustrates the divide we see during atmospheric re-entry. Candidates who input generic answers experience rapid orbital decay. They write down a formula, do some math in a vacuum without specific linkage, and miss the larger picture. Pilot Sam does exactly this, ignoring the boundary constraints of the actual scenario. Meanwhile, the candidates who tie their evidence-based reasoning directly back to the specific context achieve a flawless approach. They recognize the why behind the what, and that makes all the difference to the principal examiners monitoring the data.
Section 3. The method mark strategy.
Now, if you want that full 15% payload, you have to realize that this flight isn't just graded on the final touchdown. The systems engineers actively reward your flight process. Your logical steps, your data interpretation, and your clear notation are actively scoring you method marks, even before you reach the final solution. It's essentially your secondary propulsion system. If you make a tiny calculation error on the final line, a strong method mark strategy ensures you still bank the vast majority of your points.
Okay, I'm overriding the console here because our crew just hit a critical roadblock mid-paragraph where their evidence links failed. But before we fire the secondary boosters to secure maximum marks and optimize your flight path, I need to pause the simulation. Subscribe to Ace the Exams at AC Exams right now and turn on all notifications. Okay, simulation resumed. To save the trajectory, I'm injecting the PEL structural template directly into your 5-step procedural framework. Step 1, deconstruct the question. Break it down into logical pieces. Step 2, extract relevant data. Pull out your variables from texts and tables. Step 3, select your analytical framework. Step 4, execute with clear notation. And Step 5, present with proper terminology. This exact deconstruct, solve, evaluate sequence ensures you systematically secure every single method mark available.
Section 4, Principal Examiner Top Warnings.
We are now entering the interactive viewer radar challenge phase. I need you tracking this live. These are the top warnings pulled straight from the examiner reports, representing the 3 unforced errors you absolutely must avoid. We call this debris detection. You have to identify where a sample student answer falls below compliance standards. 1. Poor formatting, which loses you incredibly easy marks. 2. Sloppy presentation and terminology. And 3, the classic mistake of failing to link your points to the specific scenario. For instance, if the prompt is a financial context about a salary increasing by a set amount every year, candidates will just leave their final answer as n equals 12. That's a system failure. You must actively state the target salary is reached in the 12th year.
Let's run simulation 2. Imagine a highly complex source graph or text block on your screen with a 60-second visual countdown clock ticking down. Could you locate the hidden core variable before time runs out? Ask yourself right now, are you treating your mathematical presentation with strict conventions? Using proper headings and clear annotation is exactly what the radar is actively hunting for. Practical application develops professional skills, and part of being an elite pilot is presenting your analytical conclusions flawlessly on the page. Don't let easy formatting marks become undetected debris.
Section 5. Final Review, Mnemonic. We are initiating the Mission Accomplished touchdown sequence. We've mapped the core theory and the procedural steps, but you need a reliable way to instantly recall it when the exam clock is ticking. The examiners suggest a powerful memory hack. Effectively, your pre-flight question scan checklist. Build your own mnemonic using the first letters of our 5 procedural steps so you never freeze under pressure. Deconstruct, extract, select, execute, present. DESEP. Build a funny phrase out of those letters, like dogs eat sausages every pencil, whatever locks it into your system. When you sit down, write that mnemonic on your paper to serve as your navigational anchor.
Pilot Alex and Pilot Sam are confirming a successful, full-mark touchdown sequence on the main console. You now have the insider advantage. You know arithmetic progressions carry that 15% payload, you have the method mark strategy, and you've mapped the examiner's debris warnings. The next time you open a past paper, remember, the examiner isn't just looking for your final answer. They are tracking your entire mathematical flight path. To keep optimizing your trajectory, subscribe to Ace the Exams at Ace the Exams, enable the notification bell, and drop a comment below sharing your specific subject and tier. Mission accomplished, and I'll see you in the next explainer.